In this video, I'm going to go through how to find the area of various 2D shapes. Now, let's start with the square. So what do we know about squares? Well, all of the sides are equal. Now, as you can see by those little red lines I've put in there, that symbolises that each side is equal. So to find the area of a square, let's just call each side B, 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 B. All it is the base, which is B, times by the height, which is also B. So let's just call this one B times B, or B squared. The rectangle, again, it's very, very similar. As you can see, you've got right angles in here, as I'm drawing. So the area of a rectangle is the base, which is this length along the bottom, times by the height, which is the vertical height here. So the area of that is the base times by height. Now, as you know, if we're just doing formula with letters, you don't need to put a multiplication sign in there. So let's try those two using numbers. So let's say that for our square, all of our lengths are 2 meters. So every single length is 2 meters. So what would our area be? Well, our area would be 2 squared, or 2 times by 2, which is 4. Now, am I done yet? No, not quite, because as we can see from the from our labelling of our original line, it's not just 2, it's 2 meters. So for an area, it's really important we use that unit of measurement, meters squared. So for the rectangle, we're going to say that the base this time is 6 meters, and we're going to say that the height is 3 meters. So if we plug those numbers into our formula, the area would be 6 times by 3, which is 18. And again, you can see that it's meters, so we've got meters squared. They're the basic ones that most of you will know already. Now it comes to parallelograms, triangles, and trapeziums. So a parallelogram is very similar to a rectangle in that we need to know our base, which is this length here, and we actually need to know our vertical height. So that's the perpendicular height compared to the base. Now, the area for the parallelogram is actually exactly the same as the area of a rectangle, but it's the base times by the vertical height. Now, a little demo to show why that's the case is if I was to draw a line down here and show that that's a right angle, and then if I was to take this triangle here and place it here, you might be able to see that I have created a rectangle. So it's exactly the same area. All it is I've shifted this triangle here over to here. And that's why the formula for the area of a parallelogram is the same as the area of a rectangle. So if I just draw a quick parallelogram down here with an example of numbers, let's say that the base for this one is 4 centimeters and the vertical height, let's say, is 2 centimeters. If we plug that into our formula above, the area is 4 times by 2, which is 8. And this time it's centimeters, not meters. Therefore, our unit of measurement is centimeters squared. Now, a triangle, similar to a parallelogram in that you need to find the vertical height of it. So we find our base, which is usually given to you, and the vertical height, which is, again, that line that runs perpendicular to the base. So it's the line that goes straight up at a right angle. So our area for the triangle is slightly different. It's not just base times height. It's half the base times by the height. Or another way of saying that is base times by height divided by 2. And all of these rules are just rules that you need to really learn. So if I was to put in numbers again for these, let's say that our base is 10 centimeters, and let's say that our height is 4 centimeters. Well, the area, if we plug those numbers in, is 10 times by 4 divided by 2. So we've got 10 times by 4 is 40, divided by 2 is 20. And again, we've got centimetres here, therefore it's centimetres squared. Now the trapezium is the one which you have to sort of learn an extra step of the formula really. So for this one, again, we're going to call the base B, that's this length here. We're going to call the height H as usual, but then the top line, because as you know with a trapezium, the base and the top line run parallel to each other, that top line we're going to call A. Now the issue we've got here is that the top line isn't always the same length compared to the base. So we need to find an average of the lengths of the top line along here and the base along here. Now to find that average, what you need to do is you need to add them together and divide them by 2. So we've got A, which is our line along the top that runs parallel to our base, plus the base, and we're going to divide it by 2. And that is how we find the average of the 2 lengths along the top and along the bottom. But then we mustn't forget about the height part over here, because at the moment we're just finding the length of something. So then we must then times that by our height. So let's put in some numbers again. So let's say that we've got our base could be 14 centimetres. The line along the top, let's say that that's 10 centimetres. And let's just say that our height is 5 centimetres. So if we plug these numbers in, A is 10. I'll put it up here. So if A is 10 plus our base, which is 14, then we've got to divide that by 2, and we're timesing it by our height, which is 5. So it looks a bit complicated at the moment, but the numbers work out quite nicely. So if I was to rewrite that, we've got 24 divided by 2, which makes 12, times by 5, which leaves our area as being 60. And again, we look at the unit of measurement, it's centimetres, so it's centimetres squared. Okay, well, I hope that was a really useful video, especially the parallelogram and trapezium, because they're the ones that might not be as obvious to many.